Picture this. You're standing on solid ground right now. Beneath your feet, the Earth feels permanent, unchanging, eternal. The sky above stretches endlessly. The horizon extends as far as your eyes can see. Everything about your daily experience tells you that Earth is vast, stable, and safe. This is the most dangerous illusion humanity has ever believed. Tonight, I'm going to shatter that illusion completely. We're going to discover something that will fundamentally reshape how you see humanity's position in the cosmos. Not through philosophy or poetry, but through cold, hard measurements. Because when you actually calculate the numbers, when you truly understand the scales involved, you realize something terrifying. Earth isn't just vulnerable, it's catastrophically fragile in ways that should keep every thinking person awake at night. Before we begin this journey into cosmic horror, hit that subscribe button and drop a comment telling me, have you ever felt truly vulnerable looking up at the night sky? Because after tonight, you definitely will. Here's what most people don't grasp. The threats to Earth's existence aren't theoretical. They're not distant possibilities we might face in some far-off future. They're active, ongoing, and statistically guaranteed to occur. The only question is when. By the end of this exploration, you'll understand why our continued existence represents the most improbable winning streak in cosmic history. You'll see why every day humanity survives is a statistical miracle that defies the universe's apparent determination to erase us. Let's start with something concrete: Earth's dimensions. Our planet measures roughly 12,742 kilometers in diameter at the equator. That's about 7,918 miles. Walk that distance at a steady pace, and you'd spend approximately 110 days in continuous motion. The surface sprawls across roughly 510 million square kilometers, about 197 million square miles of terrain. These numbers sound substantial. They feel massive when you're standing at ground level, watching the horizon curve away into the distance. Ancient civilizations genuinely believed Earth stretched infinitely in all directions, that the ground was the universe's foundation, unshakable and endless. They were catastrophically wrong. The moment you gain altitude, the moment you rise above Earth's surface and look back, everything changes. Astronauts describe this experience with words like fragile, delicate, paper thin. They report seeing Earth not as the massive, eternal sphere we imagine, but as a vulnerable bubble of blue floating in an infinite darkness that seems actively hostile to its existence. Consider atmospheric thickness. The breathable air you're inhaling right now exists only within the lowest 12 kilometers of atmosphere. Above that, you'd suffocate within seconds. The entire atmospheric envelope, the complete protective layer shielding 8 billion humans from instant death, extends roughly 100 kilometers above the surface. 100 kilometers. That's the distance you might drive to visit relatives. That's how thick the barrier stands between you and the absolute vacuum of space, where your blood would boil, your lungs would collapse, and you'd freeze and burn simultaneously. If you constructed a scale model where Earth matched a basketball size, the atmosphere would measure thinner than a sheet of paper wrapped around its surface. You could scratch it off with your fingernail. That's the shield protecting every human who has ever existed. Drop a like if this is already making you uncomfortable, because we're just getting started. And the cosmic threats get so much worse from here. Let's examine what stands between you and instant annihilation. The Kármán line, the officially recognized boundary where Earth's atmosphere ends and space begins, sits at just 100 kilometers above sea level. Driving at highway speed, you'd reach this boundary in roughly 55 minutes. 55 minutes of driving separates breathable air from lethal vacuum. The atmosphere contains several distinct layers, each progressively thinner than the last. The troposphere, where all weather occurs and where we live, extends only 8 to 15 kilometers upward, depending on latitude. Commercial aircraft cruise at the troposphere's upper boundary. Everything that has ever lived, every forest, every ocean, every creature exists within this impossibly narrow band. Above the troposphere lies the stratosphere, reaching approximately 50 kilometers altitude. This layer contains the ozone layer, which absorbs the sun's ultraviolet radiation. Without this molecular shield, UV radiation would sterilize Earth's surface within months. Every DNA strand in every living cell would shatter under the bombardment. The mesosphere extends to roughly 85 kilometers. This is where meteors burn up, a constant reminder that space debris bombards our planet continuously. Only this thin atmospheric friction prevents rocks from raining down every second. Beyond that, the thermosphere stretches to about 600 kilometers, but it's so diffuse that it barely qualifies as atmosphere. Satellites orbit here, and even they experience atmospheric drag that gradually pulls them back toward Earth. Here's the terrifying reality. At just 19 kilometers altitude, the height military reconnaissance planes reach air pressure drops so dramatically that your blood would literally boil at body temperature. Without a pressure suit, you'd have approximately 15 seconds of useful consciousness before passing out permanently. At 30 kilometers, the sky turns black even during daylight. You can see space is void despite the sun blazing overhead. At 80 kilometers, there's barely any air remaining. You're essentially in space, even though you haven't technically crossed the official boundary yet. Comment below, does knowing you're separated from space by less than an hour's drive change how you see Earth? I want to hear your thoughts. This atmospheric shield is held in place purely by Earth's gravity. It's not a solid dome. It's not an energy field. It's just gas, loosely clinging to the planet through gravitational attraction. And gravity can fail to hold it. We've watched this failure happen. Mars once possessed a thick atmosphere, potentially capable of supporting liquid water. But Mars lost its magnetic field approximately 4 billion years ago. Without that magnetic protection, the solar wind, a constant stream of charged particles blasting from the sun, slowly stripped Mars's atmosphere away, molecule by molecule. Today, Mars retains less than 1% of Earth's atmospheric pressure. It's a frozen, radiation-bombarded wasteland where nothing can survive, exposed on the surface. Earth still has its magnetic field, for now. But magnetic fields aren't permanent fixtures. Earth's field has reversed numerous times throughout geological history, and during these reversals, which can take thousands of years to complete, the field weakens dramatically, sometimes dropping to 10% of normal strength. What happens then? The solar wind starts eroding our atmosphere. Not dramatically, not overnight, but molecule by molecule, year by year, our shield begins leaking into space. Space isn't empty. This is the first dangerous myth we must demolish. When you observe the night sky, you see darkness punctuated by distant stars. It appears peaceful, serene, safe. It's a killing field. Right now, at this precise moment, over 25,000 known near-Earth asteroids exist. These are objects large enough to cause catastrophic damage if they strike us. And here's the nightmare detail. Those are merely the ones we've discovered. Thousands more remain undetected, lurking in orbits that intersect Earth's path, invisible until they're nearly upon us. Every single day, approximately 100 tons of dust and sand-sized particles enter Earth's atmosphere. Most burn up harmlessly, creating the meteors you see as shooting stars. These are the bullets that miss, or more accurately, the bullets our atmosphere can stop. But larger objects hit us too. Every year, an asteroid roughly car-sized enters Earth's atmosphere. These typically explode in the upper atmosphere, releasing energy equivalent to several kilotons of TNT. In February 2013, a 20-meter asteroid exploded over Chelyabinsk, Russia, with a force of 500 kilotons, roughly 30 times the Hiroshima bomb's energy. The shockwave injured over 1,500 people, primarily from shattered glass. The object was relatively small by cosmic standards, and we never saw it approaching. It came from the sun's direction, where our telescopes were essentially blind. This happens every few decades, but the real threat comes from larger objects. A city-killer asteroid large enough to level an entire metropolitan area strikes Earth roughly every 1,000 to 10,000 years. We're statistically overdue. These impacts would release energy equivalent to hundreds or thousands of nuclear weapons detonating simultaneously. Every few million years, Earth receives a civilization-ending impact, an object massive enough to trigger global catastrophe, ecosystem collapse, mass extinctions. If this is making your heart race, hit that like button and subscribe, because understanding these threats is the first step toward maybe, possibly surviving them. We know this pattern because it's happened repeatedly. 66 million years ago, an asteroid approximately 10 kilometers in diameter struck the Yucatan Peninsula. The impact released energy equivalent to 10 billion Hiroshima bombs. 10 billion. The explosion vaporized the asteroid and a massive chunk of Earth's crust instantly, sending a superheated plume into the stratosphere. Within hours, debris rained across the entire planet, igniting wildfires on every continent. The sky turned black with soot, temperatures plummeted, photosynthesis stopped globally. The food chain collapsed from the bottom up. 75% of all species went extinct, including every dinosaur larger than a chicken. The dinosaurs had ruled Earth for 165 million years. They survived ice ages, volcanic eruptions, climate shifts, everything the planet threw at them. They were the most successful large animals in Earth's history, and they were erased in an afternoon by a falling rock. Here's what keeps astronomers awake. We only started seriously tracking near-Earth asteroids in the 1,990 seconds. Before that, humanity was completely blind to these threats. For all recorded history for the entire span of human civilization, we had no idea what was orbiting out there. Even now, our detection systems have massive blind spots. We can only see asteroids when they're illuminated by the sun and visible against space's darkness. Let's discuss the Sunday. Every morning it rises, every evening it sets. Your entire life, it's been a reliable constant, a warm yellow disk providing light and heat. We think of the sun as gentle, predictable, safe. This perception is lethally naive. The sun is not a light bulb. It's a continuously detonating thermonuclear bomb held together only by its own crushing gravity. It's a plasma sphere, 1,391,000 kilometers in diameter, with core temperatures reaching 15 million degrees Celsius. Every second, it converts 620 million tons of hydrogen into helium through nuclear fusion, releasing more energy than human civilization has produced throughout its entire existence. This cosmic furnace sits just 150 million kilometers away. That sounds distant, and by human standards it is. But in cosmic terms, we live directly adjacent to a stellar explosion, and that explosion aims at us constantly. The sun doesn't merely shine peacefully, it erupts constantly. Solar flares, massive explosions on the sun's surface, release energy equivalent to millions of nuclear bombs within minutes. Coronal mass ejections hurl billions of tons of superheated plasma into space at speeds exceeding 6 million kilometers per hour. Most eruptions miss Earth. Space is vast, and even the sun's most violent outbursts usually blast harmlessly into empty void. But occasionally, every few decades or centuries, one strikes us directly. In September 1859, a massive solar storm struck Earth. Called the Carrington event after astronomer Richard Carrington, who observed the triggering flare, this CME hit Earth's magnetic field like a cosmic battering ram. Auroras appeared as far south as the Caribbean. The northern lights were so brilliant in the Rocky Mountains that miners woke at 2 a.m. thinking it was dawn. But the beauty masked destruction. Telegraph systems, the era's most advanced technology, went haywire. Telegraph operators reported shocks and burns. Some lines burst into flames. Papers spontaneously ignited on telegraph desks. This was 1,859. Humanity barely used electricity. We had no power grids, no satellites, no computers. Share this video if you're realizing how vulnerable our modern world actually is. Hit subscribe so you don't miss what comes next about supervolcanoes and magnetic collapse. Now imagine the Carrington event happening today. The solar storm would hit Earth's magnetosphere, compressing it violently. Electromagnetic pulses would race through power lines, overloading transformers and substations. Power grids would collapse across entire continents within minutes. Satellites would be fried by radiation. GPS would fail. Communications networks would go dark. The International Space Station's astronauts would face lethal radiation exposure. But the real catastrophe would unfold on the ground. Modern civilization runs on electricity. Water treatment plants need power. Hospitals need power. Food distribution networks need power. High voltage transformers aren't mass produced. They're custom built and take months to manufacture. If hundreds or thousands are destroyed simultaneously, the global supply chain couldn't replace them quickly. Some estimates suggest a Carrington-level event today could leave portions of developed nations without power for 4 to 10 years. 4 to 10 years without electricity, without refrigeration, without modern medicine, without clean water, without food transport. Death toll estimates range from millions to billions. We've examined threats from space asteroids, solar storms, the dying sun day, external dangers hurtling toward us from the cosmic void. But some of Earth's deadliest threats aren't approaching from above. They're already here, buried beneath our feet, waiting. Supervolcanoes. Most people think of volcanoes as mountains that occasionally erupt. Mount St. Helens, Mount Vesuvius, Krakatoa. These are destructive, certainly, but localized. They destroy cities, not civilizations. They kill thousands, not billions. Supervolcanoes operate on an entirely different scale. They don't build mountains, they collapse them. And when they erupt, they threaten the entire planet. Approximately 20 known supervolcano sites exist on Earth. The largest and most famous is the Yellowstone caldera in Wyoming, USA. Tourists visit Yellowstone National Park annually to observe geysers and wildlife, completely unaware they're standing atop one of Earth's most dangerous geological features. Beneath Yellowstone lies a magma chamber, approximately 60 kilometers long, 30 kilometers wide, and up to 8 kilometers deep. This chamber contains roughly 25,000 cubic kilometers of molten rock, enough to fill the Grand Canyon 11 times over. Yellowstone has erupted 3 times in the past 2.1 million years. The first eruption, 2.1 million years ago, ejected 2,500 cubic kilometers of material. The second, 1.3 million years ago, ejected 280 cubic kilometers. The third, roughly 640,000 years ago, ejected 1,000 cubic kilometers of ash, rock, and debris into the atmosphere. These numbers sound abstract until you understand what they mean physically. When Yellowstone last erupted 640,000 years ago, it ejected 1,000 cubic kilometers in days, possibly hours. This wasn't lava slowly oozing down a mountainside. This was an explosion so violent it ejected material into the stratosphere at supersonic speeds. The eruption left a caldera, a collapsed crater that's 72 kilometers across. You can't even see the entire caldera from ground level. Early geologists didn't realize Yellowstone was a volcano at all. Ash from the eruption blanketed half of North America. Deposits over 1 meter thick have been found as far as California, Texas, and Louisiana. The ash clouds circled the globe, blocking sunlight and dropping global temperatures by several degrees for years. Comment below, did you know Yellowstone was a supervolcano? And more importantly, does knowing this change how you see those beautiful geysers? Let me know your thoughts. Here's what keeps geologists awake at night. Yellowstone erupts roughly every 600,000 to 700,000 years. The last eruption was 640,000 years ago. We're statistically overdue. If Yellowstone erupted today with the same intensity as 640,000 years ago, everything within 800 kilometers would be buried under meters of hot ash. The ash would contaminate water supplies, collapse roofs, ignite fires. Breathing the ash would be like inhaling ground glass. It would shred lung tissue. But that's just the immediate destruction zone. The real catastrophe would be global. Ash in the stratosphere would block sunlight for years. Global temperatures would drop by 5 to 10 degrees Celsius, enough to trigger a volcanic winter. Crops would fail worldwide. Growing seasons would shorten or disappear. The global food supply would collapse. Estimates suggest a Yellowstone supereruption could kill millions directly, but billions could die from starvation in the following years. Let's discuss the invisible shield keeping you alive. You can't see it, you can't feel it, most people don't even know it exists. But without it, Earth would resemble Mars, a barren, frozen wasteland. Earth's magnetic field. The magnetic field generates deep within our planet, roughly 2,900 kilometers below the surface, in the outer core. Here, liquid iron heated to temperatures exceeding 5,000 degrees Celsius flows in complex patterns, creating electric currents. These currents generate a magnetic field extending thousands of kilometers into space, forming a protective bubble around Earth called the magnetosphere. This invisible shield deflects the solar wind, a constant stream of charged particles blasting from the sun at speeds exceeding 6 million kilometers per hour. Without the magnetosphere, the solar wind would strip away our atmosphere molecule by molecule, exactly as it did to Mars billions of years ago when Mars lost its magnetic field. Mars once possessed a thick atmosphere. Evidence suggests liquid water once flowed across its surface, carving river valleys and filling vast oceans. But approximately 4 billion years ago, Mars's core cooled and solidified. The magnetic field died. Without protection, the solar wind began eroding the Martian atmosphere. Today, Mars retains less than 1% of Earth's atmospheric pressure. The average surface temperature sits at -60 degrees Celsius. Any liquid water instantly freezes or evaporates. Mars is a dead world, killed by the loss of its magnetic shield. Earth still has its magnetic field, for now. But here's what most people don't realize. Earth's magnetic field isn't permanent. It's not stable, and is not guaranteed to last forever. The magnetic field flips. North becomes south. South becomes north. And it's happened hundreds of times throughout Earth's geological history. These reversals occur roughly every 200,000 to 300,000 years on average, though intervals vary wildly. Some reversals are separated by less than 100,000 years, others by more than 1,000,000 years. There's no predictable pattern. The last reversal, called the Brunhes-Matuyama reversal, occurred approximately 780,000 years ago. We're statistically overdue. Hit that subscribe button and turn on notifications, because understanding these existential threats might be the most important knowledge you gain this year. But here's where it gets truly terrifying. The reversal process doesn't happen instantly. It's not like flipping a switch. Magnetic reversals take hundreds to thousands of years to complete a geological eye blink, but an eternity in human terms. And during that transition period, while the magnetic field reorganizes itself, it weakens dramatically. Studies of ancient lava flows, which preserve a record of Earth's magnetic field strength when they solidified, show that during reversals, field strength can drop to 10% or less of normal intensity. Some evidence suggests the field might nearly vanish entirely during transition, leaving Earth almost completely exposed to solar radiation and cosmic rays. What happens when the shield fails? Increased radiation. Cosmic rays, high-energy particles from exploding stars and other cosmic sources, constantly bombard Earth. Our magnetic field deflects most of them. But if the field weakens by 90%, radiation exposure at Earth's surface increases dramatically. Satellites would be fried. Commercial air travel would become dangerous. The ozone layer would thin. Ultraviolet radiation reaching Earth's surface would spike. Skin cancer rates would soar. Plankton, microscopic organisms at the ocean food chain's base would die off in massive numbers. Let's zoom out beyond Earth, beyond the sun, beyond our solar system. Because the threats to our fragile existence don't stop at the edge of our cosmic neighborhood. They extend across light years of space, lurking in the darkness, waiting to explode. About 650 light years away, roughly 6,100 trillion kilometers, there's a star called Betelgeuse. It's a red supergiant, one of the largest stars visible from Earth. If you placed Betelgeuse at our solar system's center, its surface would extend past Mars's orbit. It would swallow Mercury, Venus, Earth, and Mars entirely. Betelgeuse is dying. Stars like our sun die slowly, gradually fading over billions of years as they exhaust their fuel. But massive stars, stars like Betelgeuse with 15 to 20 times the sun's mass, die violently. When they run out of fuel, they don't fade, they explode. Supernova. Betelgeuse is in its final life stages. It's already exhausted the hydrogen in its core and moved on to fusing heavier elements: helium, carbon, oxygen, silicon. Each fusion stage lasts shorter than the last. Hydrogen fusion can sustain a star for billions of years. Silicon fusion, the final stage before collapse, lasts only days. When Betelgeuse exhausts its silicon fuel, the core will collapse in less than 1 second. The outer layers will rebound off the ultra-dense core and explode outward at 10% light speed. For a few weeks, Betelgeuse will shine as brightly as an entire galaxy, 100 billion stars worth of light concentrated in a single exploding point. From Earth, 650 light-years away, the supernova will be spectacular. Betelgeuse will suddenly brighten to rival the full moon. You'll be able to see it during the day, a second sun hanging in the sky, visible even at noon. At night, it will cast shadows. You'll be able to read by its light. Sounds beautiful, right? Poetic, a cosmic light show. It's a threat. Drop a comment. Did you know a nearby star explosion could damage Earth? Share your thoughts below, and don't forget to like and subscribe for more cosmic reality checks. When a massive star explodes, it doesn't just release light. It releases gamma rays, X-rays, and high-energy particles traveling at nearly light speed. Most supernovae are far enough away that by the time their radiation reaches Earth, it's been diluted to harmless levels by vast distances. But Betelgeuse is relatively close. 650 light-years is nothing in galactic terms. While it's far enough that the supernova won't sterilize Earth, it's close enough to cause serious damage. The gamma rays and X-rays from the supernova would hit Earth's atmosphere within days of the visible light arriving. These high-energy photons would interact with nitrogen and oxygen molecules in the upper atmosphere, creating nitrogen oxides, the same compounds that deplete the ozone layer. Studies suggest a supernova at Betelgeuse's distance could deplete Earth's ozone layer by 20% to 50% in the hemisphere facing the explosion. The depletion would persist for years as nitrogen oxides continue breaking down ozone faster than it can replenish. With the ozone layer compromised, ultraviolet radiation from the sun would reach Earth's surface at dangerous levels. Skin cancer rates would spike, ecosystems would be disrupted, agriculture would struggle under increased UV stress. It wouldn't be an extinction event, not at 650 light-years, but it would be a global catastrophe, as Etev overseed. We've discussed asteroids we might detect, solar storms we might predict days in advance, supervolcanoes that give weeks or months of seismic warning, magnetic reversals taking centuries or millennia. Even supernovae give us the mercy of visibility. We see the explosion at the same moment radiation arrives. But now we must confront the nightmare that keeps astrophysicists awake at night. The threat that makes every other danger look manageable. The cosmic assassin's bullet that could end everything in seconds without warning, without mercy. Gamma ray bursts. Gamma ray bursts, GRBs, are the most energetic explosions in the universe since the Big Bang itself. For a few seconds, sometimes less than 1 second, a gamma ray burst releases more energy than the sun will produce in its entire 10 billion year lifetime. More energy than the sun will produce in 10 billion years, released in seconds. These aren't just explosions, they're cosmic cataclysms, the universe's equivalent of a stellar execution. Gamma ray bursts occur when the most massive stars collapse into black holes, or when neutron stars' ultra-dense remnants of dead stars collide and merge. During these catastrophic events, collapsing or colliding matter forms jets of gamma radiation that shoot from the poles at nearly light speed. These jets are focused like laser beams. If you're in a GRB jet's path, you see the most powerful explosion in the universe. If you're off to the side, you see nothing. The beam is narrow, typically a few degrees wide, so most GRBs in the universe point away from Earth. We never see them. They explode in silence, firing deadly beams into empty space. But occasionally, every few thousand years in our galaxy, one points at us. In 2004, a GRB, from a magnetar, a neutron star with an insanely powerful magnetic field located 50,000 light years away, hit Earth's upper atmosphere. Even at that immense distance, the burst was so powerful it ionized the upper atmosphere, disrupted radio communications, and temporarily affected Earth's magnetic field. The 2004 event was relatively weak and incredibly distant. It caused no lasting damage, but it was a warning. If this video is making you realize how vulnerable we truly are, please share it, hit subscribe, and that notification bell. Knowledge like this needs to spread. Now imagine a GRB from a closer source. Not 50,000 light years away, but 10,000 light years, or 5,000 light years, or even closer. Here's what would happen if a gamma ray burst from 6,000 light years away, pointed directly at Earth and fired. The gamma radiation would hit Earth's atmosphere, traveling at light speed. No warning, no time to prepare. One moment, everything is normal. The next moment, the sky lights up with a flash of blue-white light, brighter than the Sunday. The gamma rays would interact with molecules in the upper atmosphere, creating a cascade of secondary particles and radiation. The ozone layer would be obliterated, not damaged, not depleted, obliterated. Studies suggest a GRB at that distance could destroy 50% of the ozone layer in less than 10 seconds. 10 seconds. That's how long it would take to strip away half the protective layer shielding Earth from ultraviolet radiation. But the ozone destruction is just the beginning. The gamma rays would also create massive amounts of nitrogen dioxide in the atmosphere, a brown gas that absorbs sunlight. The sky would turn brownish orange, temperatures would drop as sunlight is blocked. With the ozone layer destroyed, ultraviolet radiation from the sun would reach Earth's surface at lethal levels. As all of the South, we've traveled through a catalog of cosmic horrors tonight. Paper-thin atmospheres, asteroid bombardments, solar eruptions, supervolcanoes, failing magnetic shields, exploding nearby stars, gamma ray bursts traveling at light speed. Each threat alone could end human civilization. Together, they paint a picture of a universe that seems actively hostile to our existence. Earth isn't just vulnerable, it's surrounded by an astonishing variety of ways to die. And yet, here we are, still alive, still thriving, still building, creating, exploring. This is the paradox we must confront. Earth is fragile beyond comprehension, threatened by forces we can barely detect and cannot control. But Earth is also home to something remarkable: life, consciousness, intelligence capable of understanding the very threats that endanger it. In 1990, the Voyager 1 spacecraft, having completed its primary mission, turned its camera back toward Earth from approximately 6 billion kilometers away and took a photograph. Earth appeared as a tiny pale blue dot, less than a pixel in size, suspended in a beam of sunlight. Astronomer Carl Sagan reflected on this image. Look again at that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. Every king and peasant, every hero and villain, every creator and destroyer of civilization, all of them lived on that dot. Every triumph and tragedy, every war and peace, everything that has ever mattered to humanity happened on that barely visible speck. This perspective should fundamentally change how we see ourselves and our world. The petty disagreements dividing us, the borders we fight over, the resources we compete for, all of it plays out on a stage so small that from modest distance, it disappears entirely. If this video changed how you see Earth and humanity's place in the cosmos, please like, subscribe, and hit that notification bell. Share this with someone who needs perspective. Comment below. Will you ever look at Earth the same way again? This doesn't make our lives meaningless. If anything, it makes them more precious. Because as far as we know, that pale blue dot is the only place in the universe where life exists. Conscious, intelligent life might be even rarer. We might be tiny, threatened by forces beyond our control, living on borrowed time before the next cosmic catastrophe strikes. But we're also carrying something potentially unique in all the cosmos: consciousness, intelligence, the ability to understand the universe. Earth is fragile. The atmosphere is paper thin. Asteroids are always falling. The sun is always burning. Supervolcanoes are always waiting. The magnetic field is always weakening. Nearby stars are always preparing to explode. And yet we're still here. Against impossible odds, in a universe apparently designed to erase us, we persist. This knowledge should inspire not despair, but determination. Understanding our fragility is the first step toward protecting ourselves. Recognizing the threats is how we begin to defend against them. Earth is vulnerable, but Earth is also home. And that small, fragile, threatened world deserves every effort we can muster to protect it. Thank you for joining me on this journey through cosmic fragility. Sleep well tonight if you can. Good night. And remember, we're all standing on that pale blue dot together.